Hello and welcome to episode 125 of Linux Dev Time. I'm Joe.
I'm Amalith.
I'm Kevin.
And I'm Andy.
Good to talk to you all again. So today, you're going to teach me the fundamentals of programming and development.
I had a friend over the other day who wanted to learn really the basics of programming. He had done some basic 30 or 40 years ago, but he basically had no clue. And he was like, okay, teach me to code. And so I took him through a bit of Python. And it got me thinking, what are the really fundamental ideas here? What is programming in some fundamental way? So I'm interested in what people think are the key ideas.
Yeah, so I guess if we broke it down to the very basic components, even before we get to language syntax and things of that nature, I would probably try and tell somebody it's giving a computer instructions, right? At its most basic level, you're giving a computer instructions to follow.
Yeah, you're telling a computer what to do, essentially.
I'm assuming pragmatically, this gentleman that you were talking to wanted to do a particular thing or in a particular type of language or construct or, wanted to make a web page, wanted to make a command line tool, whatever it was, right? There was something that they wanted to accomplish. And what you're wanting to accomplish, that will determine the fundamental aspects of it, because there's some things for example, if someone was learning kernel development, right? They'd need to understand some very low level primitives. But if someone was learning how to build a new web page, they wouldn't necessarily need to learn the low-level primitives. They need to learn some other higher-level primitives that the kernel developer wouldn't be concerned with. So I guess it depends on what exactly you're trying to do.
Yeah, but I do think there are some things that are common between them. So in terms of giving the computer instructions, right, the first thing that you need to get your head around is you give them one instruction at a time. You say, do this, then do this, then do this. And the way we tend to do that is we write them the first one at the top and then the second one on the line below and so on, assuming we're doing it textual programming language. So just a series of steps is kind of the first idea I think you probably need to get your head around.
I think that's why I've started off with scripting languages. If someone really wants to get into whether they call it programming or into some kind of development, because scripting languages I think are very easy to wrap your head around. I run a command that does a thing. They have a very tangible input and output.
Yeah, the only development or coding I do is shonky bash scripts. And that is generally do a thing and do another thing and do another thing. And yeah, so it's a very linear thing. Do this thing first, then do the next thing, then do the next thing, then do the next thing, etc.
I think the hard part with Bash or several scripting languages, though, is as soon as you get beyond that do one thing, do the next thing in serial, you very quickly get into some of the other fundamentals maybe variables or conditionals. And unfortunately, I think Bash has pretty poor support for those types of things. So while it's easy to get started in the very, very linear fashion, even though you're only stepping up to the very next basic building blocks, in Bash, those happen to be some poorly constructed items, is one way to put it.
Well, it's funny you mentioned that this person had learned a little bit of programming 30 or 40 years ago. I felt very seen there because that's me. About 30 or 40 years ago, I learned a little bit of basic 10 print hello world, 20 go to 10 run, that sort of thing. And I did progress a little bit beyond that, but then I got to for and next loops, and that's where it lost me.
Yeah, so Andy, I'm interested to hear which fundamental building blocks did you break down for this gentleman, or which one would you do in a hypothetical world?
Yeah, so I didn't do it on, what I wanted to do in my head was a conceptual level of these are the important concepts, but that's what we're doing here. But I actually had to do it in a much more practical way with this bloke. But what I went through with him was quite a classic first program, which is a guessing game where the computer thinks of a random number and then you guess and it tells you that was too high or that was too low, and then you get another go. And that gives you access to a couple of concepts. It gives you access to looping, which is what Joe was just talking about. And it gives you access to decisions. So I think both of those are really fundamental because we just said that you go through step by step, but actually sometimes you don't go through step by step. Sometimes you jump back and loop around and do the thing again. And sometimes you make a decision and go one way or another.
Yeah, if this thing happens, do this. If this other thing happens, do that.
Exactly. And even that, as an abstract concept, that's quite weird. So when you've just got your head around, you start at the top and you go down line by line, and now we're saying, oh, actually, but in this case, you jump to here when that happens, not here. It's already complicated. Don't think about it too much.
I've taught some introduction to Python courses before, years back, And I found that even sometimes the concept of like a variable was a little bit difficult. Now, when you relate it back to like high school algebra, I think everybody has those types of experiences, so they can conceptually relate, but sometimes it was a little bit difficult just to even grasp, like, wait a second, this thing represents something like kind of like a bucket, and I don't know what's in the bucket until I look at it. So even that was a little bit difficult. But then when introducing things like conditionals or, that if-else style logic or looping, like some of those things inherently involve some earlier principles, like looping inherently involves some kind of a conditional. So teaching conditionals before that, right? And then conditionals can sometimes involve some kind of a variable, right? So doing some things in those structured ways I've found helps. But have you found, like when teaching the concept of a variable, have you found anybody that struggled with that, or have you found ways to teach that concept as a basic building block?
Well, Emily, what is a variable anyway?
Well, like Kevin said, it's a bucket that stores some stuff. It could be a string, it could be a number, it could have types. It might not have user-facing types, but the interpreter in the back end will assign some sort of type to it.
So a type is like the type of thing it is, right? So it might be a number, or it might be a sequence of letters, which we normally call a string, or it might be some complicated combination of stuff. But each of those things is a type.
One way I found to describe that is if you tell people, like, you break all this down, everything goes down to the ones and zeros, right? At the very, very smallest level, down to the ones and zeros. And if you think of a variable, or not even a variable, but a thing as a sequence of ones and zeros, the exact same sequence of ones and zeros can be interpreted to have different meanings. So at I think the smallest level, right, we could just have a single 1 or a 0, and we could say that is either true or false, right? We could also interpret a 1 or a 0 as a literal number, 1 or 0, right? So the type is, how do we interpret the data that is behind the thing? Do we interpret it as a true or false? Do we interpret it as a number? Do we interpret a whole bunch of ones and zeros as multiple numbers? Do we interpret them as a string or, grouping of characters, right? It's all just how are we interpreting the data.
For example, it could be a number or a character. So it could be either a number 3 or a letter.
Exactly. The more you think about variables, the more confusing they are, because they're a bucket where you put stuff, like we said. So basically, they're like a place where you can put a thing, and then that thing might change later, and you can refer back to it later. And they're also a thing that has a type, like we were just talking about, but they're also just a way of naming something. So they're like at least 3 things in at once. One of the other key concepts of programming is that you can give something a name and then refer back to it later. So sometimes that's a variable, but sometimes that's a chunk of code, which we would call a function, or it could be like a way of collecting together data, like a person would be like their first name and their second name or whatever. Then using that word person to refer back later to, when I have a group of data that's in this structure, I'm going to call that person. Or with a function, it would be this sequence of instructions that I'm going to do again later. I give that a name, and then I can refer to it later. And similarly with a variable, it might just be, you might need pi if you're doing some maths. So you could just, every time you need pi, you could just write out 3.14159, or you could put that into a constant or a variable, which is just a way of naming it so that you can refer back to it later. So that concept even in itself is a bit weird.
So a function contains variables and types then?
I think a way to think of a function is that it is a section of code.
Yeah.
And that section of code probably contains variables, which themselves may or may not have types, and other code elements.
Yeah, I think the best way to think of it is as like a mini program, right? Because it has inputs and outputs as well as being a set of instructions.
But it's not one line, it's several lines of code that accomplish one small part of a bigger program.
Exactly.
Yeah, it's a way to reuse sections of code. So if you have let's say like a very silly function that just adds 2 to something, whatever that something is that you give it, you could, instead of writing the something plus 2 all over the place, you could say the add 2 grouping of code, and you give it the thing to add 2, and it returns back the answer.
And this is a really core idea, that by giving something a name, you get to reuse it. And by giving some other thing a name that uses other things with names inside it, you end up with bigger and bigger structures that are built out of the smaller stuff. And that's how your brain can handle complicated stuff, because it doesn't have to think about everything inside when you're talking about that higher level thing.
This puts me in mind of web pages, where you kind of break that down into different sections, and then you can link to a certain section with the hash or octothorpe, whatever it is, and the name of the section that you want to link to.
Exactly the same thing. Like whenever humans do stuff with knowledge, they always have to break it into sections that they can refer back to so they can handle it.
In many languages, environments not only provide functions as a way to group code and call it or, reuse it again, but they provide other constructs as well, whether it be modules or different files. Like every different language has a different way of kind of including some bit of code to be able to reuse again.
Okay, this episode is sponsored by people who support us with PayPal and Patreon. Go to linuxdevtime.com/support for details of how you can support us too. Patreon supporters have the option to listen to episodes without ads like this. And it's not just this show. There's Late Night Linux for news, discoveries, audience input, and misanthropy, 2.5 admins about system administration, Linux Matters for upbeat, family-friendly adventures, Linux After Dark for silly challenges and philosophical debates, Hybrid Cloud Show for everything private and public cloud, and Ask the Hosts for off-topic questions from you. You can even get some episodes a bit early. We've got a lot going on, and it's only possible because of the people who support us. So if you like what we do and can afford it, it would be great if you could support us too at linuxdevtime.com/support.
So we've talked about going through step by step, and we've talked about giving things names and having places to put things, and we've talked about reusable bits of code or mini programs. There is one other thing, which is like collecting together pieces of data. So if you want a variable that refers, like I said, to a person, not just to a single name of a person, then you make a thing which in some languages is called a class or a struct, which is a way of gathering together multiple pieces of information and then having just one name that refers to them.
So you can, for example, create a variable named Steve and set that equal to a person, and then fill out that person's struct with Steve's information. Like person might have name, birth date, and address. So then every time you refer back to Steve, instead of having to write out Steve's name, you can just refer to steve.name or something like that.
One way that I've found that's been beneficial to explain that as like a first principles type thing is to think of a struct or a class kind of like a form. Now, some people maybe like developers may be screaming into their radio or into their player listening to that, but I found that like some people can conceptualize that a lot better. It's a form. It's a grouping of fields that people have to fill out. You have to fill out each field, and then you can collectively refer to that person's form or, that object's form.
And then if we're going to do classes and structs, we really ought to do their kind of converse thing, which is, so instead of collecting together lots of information, this and this and this and this, the other thing that you sometimes want is to say something is either this or that. So you might say, I don't know, it's either a car or it's a lorry. It can't be both of those things. And there'll be no point keeping the lorry-based information in something that's a car. So you have this way of saying it's either a car or a lorry. And if it's a car, it's going to have this data in it. And if it's a lorry, it's going to have that data in it. And that is well represented in some languages and poorly represented in some other languages. So if you don't have that, you have to kind of find ways of working around it, like have a separate variable that says, is this a car or a van? And then a second variable for the information about it.
And then with that, I guess that leads into conditional statements where you have some sort of test that you want to perform. And then based on the results of that test, you have multiple different avenues or paths that you could take. So you could do something like, is this a car? Is this a truck? Is that a lorry?
Yes.
Yeah, what's a van though? I don't know why I chose such a difficult word. Sorry.
So based off of what it is, you can say, is this one thing or is it another? And then depending on that, you can go down a whole separate branch of code. You can start executing different statements based off of the result of that. And that would be called a conditional.
Yeah. So then I feel like we might have covered the kind of basic ideas of how a program works. Like you go down step by step, you make decisions, like Kevin was just saying, switching to this thing or that thing. You put stuff in variables, you collect data together, and you could call out to functions, which are little mini programs that do their work and then send you back an answer. But then you start looking for, like, the next level is things that are references to other things. And that's where life gets difficult. So some people say, you reach a certain level as a programmer when you can understand pointers.
And then other people say you've only reached the truly high levels of programming when you don't understand pointers at all.
All right. What is a pointer then?
Go on, Emilith.
I don't know. Kevin, explain it. I could take a stab at it, but I'd probably be wrong.
Or you might be wrong and right at the same time, because that's how most pointers function.
There's some languages that have pointers in them which are like specifically named as this thing called a pointer. But every language has this idea that you're referring to something else, and the reference itself is different from the thing that you're pointing at.
So some people might ask, like, how is that different than a variable?
Yeah, and it's a type of variable.
And that's where I think it gets a little bit confusing at the beginning, is often you store a pointer in a variable. And the pointer itself, what it is basically an address. It's an address to some location in memory at its most basic form. And what will happen under the hood is if you refer to this variable, when you look inside the bucket, you see an address. What the computer then does is it goes and runs to that address in memory and sees what's there. Now, where it gets complicated is the what's there is, remember, just a bunch of ones and zeros, and we have to know how to interpret those ones and zeros. So there needs to be ways to carry the type information of the actual thing that is being pointed to so that we use it correctly. Because if we have, for example, let's say, a single one or a zero that we're pointing to, we run off to that address and we see a one that's physically located there in memory. But we don't know how to interpret that. We don't know if we should interpret that as true or we should interpret that as the number one. Like, there's any number of ways we could interpret that. And if we have multiple ones and zeros, then there's even more ways. So pointers get complicated fast, but at their most fundamental level, it's really just an address to some other location in memory where we can run off and see what's at that address in memory. I guess the next question would be, why would you even want that? And that would be mostly because you can store, well, there's a bunch of different reasons why you would want a pointer over something else, but one of the reasons is we can store, memory is very, very large, and we can store all kinds of things there. However, you can't necessarily store the entire contents of the bucket all the way back into your program, like into the single variable. And some languages kind of paper over this by making it seem like you can. So it gets a little strange. And that's why I was saying at the beginning, why it may matter what exactly you're trying to do, which language you're using, as to which constructs you learn and how you learn them, because sometimes the language itself will kind of paper over these details and make them a little bit easier than they are.
To me, this sounds like symlinks.
Yeah.
It's like I have a small partition, but I want to have files that live on a larger partition or disk somewhere else. And so I just symlink it.
That's exactly a perfect analogy. And this is why I say, even though the word pointer only exists in some languages, the concept of references exists everywhere. And the key thing about them is they point at something, and they point at something useful and real, but the reference itself has a life of its own, right? That's the difference between this and a kind of more normal variable. And what I mean by a life of its own is, if we had, what's a good example? Let's try a car again. So if we have a car, and cars can carry stuff in their boot,
Trunk.
but instead of you actually wanting to store the person in the boot, you want to store the home address of the person in the boot, then that piece of paper that holds the address is like a pointer or a reference, and it has its own life. And in particular, you can replace that with a different piece of paper with a different person's address on it. And you haven't changed the person, you've just changed the piece of paper. And so getting your head around the fact that this is a thing that refers to another thing and it has an existence of its own is when things get tricky with pointers.
Yeah, I think another way to think about this as well is you could take, if we go back to our bucket example, and let's say inside the bucket, we want to store some famous painting, the Mona Lisa or something. You could either A, paint the Mona Lisa and put it inside the bucket, which would be very time consuming, very difficult to do. And let's say at some point you have another piece of artwork that you want to reference, like Starry Night or something. Again, if you wanted to replace that, you could repaint the whole Starry Night thing, place it inside the bucket, and that would also be very time consuming. However, if you already have these two pieces of data somewhere off, we'll call it main memory, like in a museum, in an art gallery.
In an NFT.
Or an NFT. You could just store the small bit of data that says where to find this piece of art inside the bucket. You want to change out to another piece of art, you just switch out that tiny little address to the new piece of art. And you haven't actually destroyed or done anything with those pieces of art. But one of the things that you have to be careful about is if the address is pointing to the museum, those paintings may no longer live at the museum at some point. They may physically get moved to another museum so other people can enjoy them. Yet if your bucket still contains the address for Mona Lisa to the original museum and someone goes there, then they don't find the Mona Lisa there. So these pointers can become out of date.
Yeah, or your symlink is useless because you deleted the original file.
Exactly. Symlinks are just a great analogy for this because they have exactly that character of they point at a real useful thing, but they also exist in their own right. And if you delete a symlink and replace it with a different symlink, then the code using that symlink won't change, but it will now work differently because it's referring to a different thing. The hardest concept in programming is there's a reference to a thing, and that reference exists and has a life of its own.
You're really telling me that symlinks are as hard as it gets when it comes to programming?
Well, imagine you have two symlinks pointing to the same file, and one person is reading from one symlink pointing to that file, and they're expecting it to be the file. Someone else is reading from the other symlink and decides to change the file through the symlink. You can end up in these very bad situations where what the person A was reading or thought they were reading changes out from under them.
Yeah, I suppose another way to think about that would be a network file system, where you might both be looking at a document, someone makes changes, saves it, and then it reloads on my machine. And because it's changed on the source, the network drive, it's now changed for me.
Yeah, exactly. Except this is all happening 1 million times a second.
Yeah. So we've discussed quite a lot of individual concepts, but how do we bring this together?
Programming in general is all about abstraction, encapsulation, and composability.
Okay, now you have to explain what each of those things means.
Maybe encapsulation and abstraction are kind of the same thing. I'm not sure. Abstraction is what we talked about before. For example, referring to a section of code with a single name. That is abstracting all of that big chunk of code into that one name. And the same for variables. You could have a whole set of data represented by a single variable name. And you can even refer to whole sets of abstractions with a single name.
And usually in an encapsulation or an abstraction type scenario, you're trying to simplify some of the details down.
Right.
So for example, you might have an abstraction called save file, right? Where all you need to do is provide the file name and the file contents. So that's the easy part in order to call the save file abstraction. Inside the save file abstraction, there could be all kinds of gory details about how to find the particular file on disk, how to open up the file, whether or not the file has the correct permissions, actually writing the data down to the disk. There's all kinds of details in there that, while relevant to the person or program that called it, are not always immediately needed. So you can abstract over that by just simplifying that down to save file with, some contents and a name. And the abstraction handles a lot of the details. You do this over and over and over again with bigger and bigger abstractions and more layers, and you eventually arrive at very complex problems or programs.
And composing all of those layers of abstractions together is what results in a final program. You can compose your code, your abstractions, your functions with a third-party library you imported.
Can I throw a spanner in the works here? Are programming languages themselves not abstractions?
Yes.
I mean, surely that's all they are, right? It's ultimately all compiled down to binaries and running as machine code. But whether you write it as C or even a higher level language like Python, the stuff that you're writing is all an abstraction.
Layers on layers on layers, all the way down.
Absolutely. And if you imagine for a second that we didn't have abstraction and the ability to combine together abstractions, then if we were trying to write even the simplest program, let's say we were trying to render a web page, but for every moment that we thought about that, we had to think about which machine code instruction I need to use to move this number from here to here, and trying to keep my head at the same time on, for example, what HTML is, it would be utterly, utterly impossible. And so, these abstractions on abstractions on abstractions on abstractions is the only way humans can deal with all this complexity.
And ultimately, you're abstracting away the hardware function.
Mm-hmm.
So how it is, like Andy said, moving bits of data around between different transistors and different areas of the CPU and what it's doing with those. Ultimately, that's what's being abstracted by these programs of add this number to that number.
That's right. Yeah, machine code is an abstraction over the way the hardware is actually operating, yeah.
And this is why no one person truly understands how all of this stuff works, right?
Absolutely. And that's more and more true every day.
Mm-hmm.
Just because there's more stuff, right? Not because people are getting more stupid. People are actually getting cleverer because there's much better tools now to understand the low-level stuff. So people really get the low-level stuff really well these days, but there's just so much stuff that goes into a normal program.
I would say that's up and down the stack too. Like you'll often hear in programming, for better, actually not for better or worse, it's definitely just worse, that the lower you are in the stack, the either the more advanced or more expert you are, which isn't necessarily true, because while some of the details at the low level are difficult, I can almost guarantee you that people that operate exclusively at those very low levels also have very little understanding of how the super high levels function either. So it's all abstraction up and down.
So the low level has a lot of complex, weird stuff about the computer and the hardware, and the high level has a lot of weird stuff about like how the web browsers work differently, or you're trying to deal with the differences between iOS and Android, or, there's a lot of nasty stuff at that level.
Or like human psychology and perception. There's all kinds of weird stuff when you start getting into the higher levels that you're not even dealing with the computer anymore.
All right, well, before we get into philosophy, I think we should probably wrap it up. We'll be back in a couple of weeks, but until then, I've been Joe.
I've been Amalith.
I've been Kevin.
And I've been Andy.
See you later.